Here's homework assignment number 19. This is probably the least understood from my aspect of the chapter that we have studied. Mainly because I didn't have an online. The people that I watch don't have anything on this section. Apparently it's not taught at a number of other universities at this level. Oh my god, why can I not even find it? There we go. Anyway, so I read through it. Didn't really understand most of it. I mean, there's some core equations that we find. Square root of k over n. Our velocities, our accelerations, sort of the same stuff, but with frequency related to sine, and we use a differential equation to figure out some stuff here. Guess if I could watch someone actually do them, it would make more sense. I'm sure it's not. An application isn't as complicated as trying to understand this book. But use a bunch of the same stuff we've already learned. Conservation of momentum, energy, yada yada. This is where it gets like there comes to be a disconnect by what is wanted from these calculations. Obviously need to go through the example problems. So here's the homework. This one's a simple oscillation, well, pendulum. Use the formulas provided. This is our hertz, and this is our 2 pi over, so we get our radians, which gives us our speed. There's our formula. Then we use this. We get our velocity. Here's our delta m. Oh my gosh, my theta. Sub m is my velocity over my length times my angular speed. Our angular speed, what is it? Oh, we don't know. Actually, we do. We got 4.8332. So we just manipulate the problem involving our other formulas. And we get that our length is 4.41995. Let me use this formula. You can set our speed equal to, or well, our angle is going to be equal to our speed divided by our length times our angular velocity. So not our speed, it's technically our velocity. That gives you your angle. Now we find acceleration is length times our acceleration tangential is our L times our alpha, which is double, don't know what you call that, double derivative of theta. Anyways. So that's what that equals. So we use this in our formula. We replace our double derivative of theta with the same value over here, and we input it into the formula over here, and then we times it all out, and we get our acceleration tangential. So that tells you how much it's speeding up. Yeah, well, it's max acceleration anyways. So then we go down here. This is a formula given. excuse me, that we set up. And this one's simpler. Use the same formula, 2 pi over WS. We know W is equal to the square root of our K, value of our stiffness, divided by our mass. And we calculate that out. We compare the two, 5 over 2. It's our frequencies, if I remember right. Periods, or whatever. Compare the two. This is what you end up getting. And then you times this over so we can calculate for using the quadratic formula for our K values. Yeah. That's that. So W equals K times our delta, KE equals mg over delta. So our mass was 5,500. 3,500, excuse me. So we got 858 millimeters. F sub n, or our frequency, is 2.4924 hertz. You convert that into revolutions per minute. So this is just a visual in our horizontal direction, our x values of just the system is mx, or m times a equals our forces in the x direction is 2kx minus our p, whatever our initial p was. Yeah. And here's another one. Mx equals p minus our force, which should be 2kx. 1/2 m r squared times alpha equals fr. So when you set it up down there, I forget what the 3m is for. Anyways. Yeah, these are all the homework problems. I mean, I understand the majority of these, but I don't know that I could do any of them without help. Especially this one, and then this one. These two are like stupid, but this one's just long, really. But yeah, I haven't looked at your videos, but to be honest, I don't generally understand any of your stuff. But I didn't have help from the people I normally watch videos on. So this is pretty much all over my head. I mean, I can follow some of it, but I don't really understand. Like, how do I know that I need to use a differential equation here? What really tells me that? I don't know. Not too enthused. Oh, I guess I should show the finished part of that. 56.9 millimeters. Yeah, I don't understand this frequency stuff at all. I'm glad I don't need to take the final. because this would kill me. I can follow math, but I don't know the concepts, what to set up for, and why to set it up. So